All right, awesome guys. Welcome. We'll wait a couple minutes before we get started. I know that it takes a couple minutes for everyone to get in the room to get stuff loaded up. There we go. We just got a flood of like
There
a
it is.
million
Oh,
messages all at once. So,
Yeah.
hey, welcome
uh,
guys. Just shout out where you're from in the chat. You know, I know a lot of you are calling in from around the world. It's 3 a.m. for some of you guys. Definitely appreciate you joining and congratulate you for your dedication. It's really incredible to see. Super excited to have all of you here. So is Randy. So is Avinash. We'll wait just a minute. Let a couple more people trickle in as we get going before we get started here, so people don't miss too much.
wow,
And
Charlotte, people
uh,
from Egypt,
already
from
here.
Mountain View, Toronto.
Jean Sebastian, what's up, man? I'm just
Can
catching
read everyone.
names as people
Wow,
just
there are people
fly through the
from
chat here.
Saudi Arabia, Tunisia. Wow, this is
Man,
amazing.
Dublin, Chicago, Toronto, Michigan, India,
Italy.
Boston.
Italy.
Okay.
There we go.
Hey, somebody from UIUC.
Nice. Very nice. So for those of you that don't know, Avinash and I both have degrees from UIUC.
College buddies.
Australia, it's 2 a.m. in the UAE. India, I know it's like 3:30 there.
Man, well, thanks
Yeah,
so much. I know I've read like 3:30 a.m. multiple times from India.
yeah,
Thanks for staying up just for this.
wow.
Awesome. So guys, I just want to say, really appreciate all of you joining. I want to say thank you to Randy. Amazing idea to have this new webinar series. I want to say thank you to Avinash for joining us as our first guest. I know you guys are going to learn a ton from him, so I'm really excited to jump into this, to start talking. You know, this is just a great opportunity for you out there to learn more what's going on in the industry from real professionals that are working in the industry right now, right? You see a lot of people posting stuff on LinkedIn, but there's also a lot of other people out there just working their job as a data scientist all day and not necessarily sharing everything they know on LinkedIn. So it's a great opportunity to reach out, find new people to connect you with, to learn about what they're doing, what's going on. And again, thanks, Randy. Amazing idea. Avinash for joining us. Randy, you wanna say a couple
Yeah.
words there?
Yeah, so I really want to say this is super exciting. This is our first episode, so I'm glad that all of you guys are here to be a part of it. And the main motive behind all of this is because we really want to connect the whole data science community together. And especially like with what Kyle said, there's data scientists everywhere. And if we have a chance to just connect with 1 hour together all in one, just to see how their whole experience, their story on how they got into the field, we can learn so much just from that. So that's the goal, that's the motive, and we just hope you learn so much from this. And thanks, Avinash, for joining. We really appreciate it.
Yeah, thank you, Randy and Kyle, for having me. It's an honor to be on the first of these Data Science Connect series, and hopefully have a lot more in the future and help out all the aspiring data scientists and the existing data scientists in the fields. And I'm glad I could be here.
Absolutely. Hey, real quick before we start. So first off, guys, I promise we'll keep you awake. I know that it's early in the morning or late at night for some of you guys. I promise we'll keep you awake. Share some awesome stuff with you. Just wanted to share a link to Avinash's LinkedIn so you guys can follow him, because I know a lot of you guys aren't necessarily following him. Randy and myself, so you can get more updates and stuff in the future as well. Hey, Randy, have you got that link handy?
Yeah, I'll
You
send
just
that
put
over
that-
right now.
Yeah, just put that in the chat there. And we've also received a ton of questions. We got like 100+ questions via email, via LinkedIn. We've taken those all down. We've organized those. We've got a lot of stuff to talk about. It's going to be a ton of fun. And then if we have more time, we're going to answer questions that are coming in live from you guys as well. So we can just go ahead. Let me try to, before this scrolls away, if I can broadcast to room and broadcast to room. Oh man, I can't broadcast more than one at a time. Let me just broadcast Avinash's here. So there's a link for Avinash's LinkedIn. Go follow him. But yeah, let's get started. So Avinash, you want to share a little bit about your background. What obviously you haven't been a data scientist your whole life, right?
Yeah.
Like where did you get started, man? What was your professional career start for you?
So previously, I was in the data science industry. I was a civil engineer. I used to work in the oil and gas industry, building oil rigs. And I came to UIUC. I came to the US for my grad school education in civil engineering. And that's when I was taking a lot of courses on optimization. We were doing a lot of studies on optimization, construction planning, how it is that we can optimize the utilization of material, manpower, and money in civil engineering scenarios. And what I was working with was genetic algorithms at that time. So one thing led to another, from genetic algorithms to high performance computing to parallel computers, cloud computing, machine learning. I just ended up doing a master's in computer science as well, along with my master's in civil engineering from UIUC. And that, in short, was my journey from civil engineering to data science.
So you were just studying civil engineering, continuing your education, and then you just started seeing an overlap in the types of problems you were solving? And is that when you
Yes,
started?
yeah, exactly. Because if you look at it, we are using.
Oh, hold on. We lost you there for a second. Lost the audio.
Is it back? I don't
There
know
we
why
go.
suddenly the audio went off. Yeah.
Yep.
So if you look at the world around us, right, we are always trying to optimize everything. And everybody is using optimization algorithms of some kind, whether it is in civil engineering, mechanical engineering, operations and research. We are trying to find the lowest cost solution, or a solution where we use the lowest amount of materials or manpower or time or whatever it is that we want to minimize, right? And there are a lot of algorithms to do that, and you can use machine learning to do that too. And it's amazing how all of these just tie up beautifully. And you can come into data science from any stream. It doesn't matter if you have done computer science or not, if you have experience in programming or not. You can always pick that up. What matters is that you have a problem solving attitude, you have a go-getter attitude to solve problems and find better solutions out there.
Right. So so then when you started studying computer science, is that when you decided you wanted to make the transition to become a data scientist? Like what was your motivation to go from being an engineer to being focused on data and algorithms?
So uh, as an engineer, I wouldn't say that an engineer is not focused on data and algorithms. It's just a different set of data and algorithms that we use. Like in construction, we had algorithms to how do you design a column, how do you design a beam. It is algorithm. It is a sequence of steps that we follow. Given a particular load, given a particular material, how do you use that material in the most optimal way to build your structure. So algorithms are everywhere. It's not just from the computer science or data science industry that we use algorithms, right?
Oh, you still there?
Yeah.
Oh, okay.
I-
All right, good. So I mean, you really just saw an overlap in terms of applications and the type of algorithms and work that you were doing and stuff.
mhm.
Um, how did you make that first professional transition then into data science?
So the first professional transition into data science for me was through this fellowship called Data Science for Social Good. And prior to that, I was already working. So I had taken a couple of courses in the computer science department. And the two main courses that I had taken were machine learning, and which was an intro to machine learning, a graduate student's intro to machine learning. And the other course I'd taken were social and economic networks. So it's not just the algorithms that you use to that you apply to a specific domain. You also need to understand the domain to which you're applying these machine learning or data science problems, right? So for that, you need to build your skill set for data science for these other disciplines such as social networks, which is I'm talking about offline social networks, about how people communicate, how economic networks work, how trade networks work, how can we apply machine learning to these paradigms. So that those two courses were my fundamental courses that helped me transition from civil engineering to data science. And then the pivotal point came during the summer of 2015 when I applied for summer fellowship at the University of Chicago. for this program called Data Science for Social Good. So during those 3 months of the summer fellowship, initially I went in hoping to learn a lot about how to do data science, and I thought I'd master data science in those 3 months in that program. But the reality of the program was that I came out of the program knowing what I don't know.
Right.
And I was equipped knowing what I don't know, what is it that I should be learning, and went to grad school back and picked up those courses, picked up the things that I didn't know, which were software engineering, statistics. I picked up a course in statistics. I learned R. I learned time series analysis. And you need to keep an open mind and try to understand what it is that you don't know, identify the courses, because each person might know something, might be really good at something, and doesn't know something else. So it is for us to identify ourselves what it is that we don't know, go out there, find the relevant courses for them, and become an expert in those fields.
Awesome. So you were able to really use your professional experience, your first internship or fellowship there, as a learning experience to guide your future growth and your future path in data science.
Yes. And also just to give you an idea of how long this timeline was, right? It took me a lot of years to actually transition from civil engineering to data science. So just to give you the timeline that I went through, I came to the US in 2013, in the fall of 2013, around this time, 5 years ago, to pursue my master's in civil engineering. And it took me one whole year to realize that, hey, it is optimization problems that I'm interested in civil engineering. So I was doing computer vision for civil engineering and optimization problems for civil engineering. Both of them had slight machine learning components, not too much, but a little bit, enough for me to sit through the machine learning course in computer science and try to understand what it is I didn't know. And if I compare myself with my peers in the machine learning course, I honestly was probably in the bottom 25% of the class. I wasn't a top student because it was really, really hard. You're using a lot of linear algebra, you're using a lot of calculus that you haven't touched in so long, especially in my case, given that I was working for 2 years where there was absolutely no use of linear algebra and calculus, right?
Right.
And you come back to this course and you're like, oh my God, what's happening? I know nothing. But it's when the going gets tough, you put in your time, you put in your effort, and you don't get deterred by the fact that you are, in the lowest 25% of your class, or you really suck at machine learning. That's okay. Everybody sucks at some point. The thing is, you just need to keep going at it, and keep getting better at it. Just don't stop.
Nice.
So it took me 1 year to actually take the machine learning class. So I started my course in 2013. It was in the fall of 2014, exactly 1 year later, when I took my first machine learning class, right? And I did that, and I spent a good time trying to understand what it is that machine learning is. And in the spring of 2014, I had taken the class on social and economic networks. These were the two pivotal classes I spoke about, right? So now, by the time I've started my master's course, it's already 2 years. It's been 2 years, and now it is that I'm figuring out that, hey, I am really interested in data science. This is what I wanted to do. I understand the nuts and bolts of what machine learning is and a little bit of what domains it can be applied to.
Right.
And that is when the summer of 2015, I applied for this data science fellowship and got accepted. Like if I'd applied a year before, I wouldn't have got accepted because I didn't have enough knowledge to prove or show that I have data science experience. And then from 2015 summer, I finished my data science fellowship at U Chicago. And then 2015 the whole year, and 2016, I graduated in December of 2016 to start my job at LinkedIn, and finally March of 2017. So a good 3.5 years from the time I started my course in civil engineering in 2013 to my data science job at LinkedIn in 2017.
Nice. So we'll circle back in a minute, and I think go into a little bit more depth about different parts of your journey. But you said you're working at LinkedIn now. Can you give us a brief overview of the types of problems that you're solving at LinkedIn and what your role is there?
So my role at LinkedIn is a data scientist, and a data scientist in the industry, even at LinkedIn, carries a broad variety of responsibilities. You can either be a vertical data scientist or a horizontal data scientist. You can be a product data scientist or a machine learning data scientist. There are a lot of different roles in data science itself. So data science is a really, really broad term, probably as broad as engineer itself. So what I do is mainly product analytics, and I'm in a role called horizontal, where I try to see what is the synergy between multiple products, where it is that we can apply common optimizations between multiple products within LinkedIn, and try to consolidate the learnings from different products. Each product has its own data scientist as well, who's working with the product, trying to help the product managers to improve the product performance, help our members get true value out of it. If they're trying to find a job, we help them try to find a job. If they're looking for interesting content on LinkedIn, we try to do that. Whatever it is that the members' intent is, we want them to successfully be able to achieve that. So that is what the role of a data scientist is. And sometimes we might realize like, hey, you know what, the UI is not well built for the member to have the best experience. So we go ahead, do experiments trying to change the UI. Sometimes we realize like, hey, the machine learning model is not really good for this certain group of members. So let's find out what that group of members is and apply a different machine learning model to them to get better results for their LinkedIn feed so that they have a much, much better experience on LinkedIn.
Right. So it sounds like it's very product focused. It's very focused on helping the business be successful.
It's focused on helping the members achieve value. It's not focused
the customers,
on business making money.
Right? Helping the customer be successful.
So
nice.
Yes, that is what. So every time we're doing any analysis, any product work at LinkedIn, we focus on what it is. Is it going to draw members of value? Like what is it that's going to help our members achieve their goal?
Yep.
And that's what we optimize for.
Yeah. So how do you measure that then? How do you go about saying, like, do you just kind of keep that in mind through the entire process? Like, how is this helping the member, or how is this helping the customer be successful? How is this helping them reach their goals? Like, what's your approach to make sure that you're always staying focused on that and you don't get sidetracked by just trying to do a bunch of cool math and stuff?
So we always ask ourselves the question, right? Like, how am I contributing to member value? So one of the core questions at LinkedIn that we are trying to answer is, how does this generate value for the members? Everything else is secondary. So even if you forget to ask this question to yourself, your peers, your manager, people who are reviewing your work are going to ask you like, hey, are you doing the right thing? Is this the right value for the members? So which is why we always, keep the members in the forefront of everything we do, and everything else is secondary. So we have metrics. We have different type of metrics. I cannot go into the details and definition of the metrics,
right.
But we have product metrics that each product has a different metric and a true north. And we use those as, a guide to what it is that the members are experiencing, what is their current experience. And we have different categories for members too. And based on those categories, we, optimize for member behavior and member experience.
Yeah. Let me ask one more quick question. I think Randy's going to jump in with some questions from the audience here too. Was that a challenge making the transition from, you went back to school and you studied computer science and machine learning and stuff in academia, and then you had to transition to a role where your goal was like, how do I focus on the customer success metrics? But that's not really covered that much in school. Did you find it challenging to be focused on like learning about machine learning and then actually applying it to a real problem to help someone in the world?
Yes. Honestly, that was a really big challenge for me. And that is something that people don't speak about in the data science industry. The thing is, when we are in academia, when we're in school, we are just taught about the machine learning algorithm in a very abstract way. We are told like, hey, this visualization is really good for this kind of data. That visualization is good for this kind of data. Use regression in this case, use decision trees in this case. If you have a ton of data, use neural networks, all that. But what it is that we don't learn is to empathize with the end user of the product. And that is something that is really, really important and honestly should be a part of the curriculum in data science. And the two biggest problems I had with initially the first 6 months at LinkedIn were empathy with the user, right? How does this help the user? How do I think about the user? And there are different kinds of user. Like if I look at myself, I count myself as a power user of LinkedIn, right? And everything I was doing was initially looking through the lens of the power user. And then it also occurred to me like, hey, I shouldn't just be keeping the power user in mind. I need to think about the users who come to LinkedIn maybe only once a week or once in 2 weeks and occasionally are looking for value from LinkedIn. Maybe as a job seeker, because I was in the US, I have a totally different experience. I need to think about how people in India are having an experience, and you need to be really, you need to empathize with your users. And that is something that they do not teach in school, and you need to pick up. And the second biggest problem that I had is storytelling. So initially, when we are doing the analysis, right, we have a beautiful graph, we have a beautiful table, and be like, hey, this is my precision, this is my recall curve, this is my AUC, etc., etc. All these metrics that we have that talk about how great our model is. But what we really need to do is also translate into how that affects the member experience, and then how it impacts the business as well. Because if it negatively impacts the member experience and positively impacts the business, some businesses might take the opportunity, some businesses might not. We do not do that, right? But sometimes, even if it helps the member value and doesn't help the business, that decision doesn't go forward. So you always need to show what is the value that you're bringing to both the members and the business, and how this helps the business as well. So those metrics of precision and recall, especially if you're a product analyst in business operations and finance, you need to be able to convert the product metrics or whatever your metrics are into an impact for the user and for the company, in terms of dollar revenue, in terms of the probability of getting a job and other things.
Nice. So it was both having empathy with the customer, and then also being able to tell the story both from the customer perspective and the business perspective.
Yeah.
Awesome. All right. Sorry, Randy. I keep cutting you off. Sorry, man.
No worries. Yeah. So I was really surprised, or it's great that you brought up the term of empathy, because it's an important concept. Because again, with this field, with all of these technical terminologies, with machine learning, a lot of people get too focused about these abstract terms, these tech stuff. But again, you got to be open-minded and realize that it's the people that you're affecting and that you're working with that really, truly matters. So back to that with empathy, one question that I've seen popped up a lot with these students or with these people here is, if they don't have experience in your case, what's a great way to actually start a project on your own and develop that mindset, develop that mentality on how to not only think of like, oh, I'm doing machine learning, but to also think about how can I apply this to any field?
Yeah. So that is a problem that every aspiring data scientist faces. And one of the things that my recommendations would be is to pick a project that you like. Like, yes, there are a ton of Kaggle projects out there that you can do, have really clean data sets. And we already know the solutions to them. A lot of the solutions are open source. You can find them on GitHub and things like that. And that's great for a stepping stone to learn how to do data science, because the first step to doing data science is imitate, right? You imitate what has already been done. You copy it. You do it again and again till you actually understand and internalize what's happening. And that's when you move into phase 2, where you have the capacity to understand which problem needs which model and which type of analysis. And that's when you go find your own data. Like, there are so many data sets out there. You can go to, especially in the US, right? The government has so many public data sets on health, on, restaurant cleanliness, on EPA statistics, on pollution, on a bunch of other things, which are not there on Kaggle. So my suggestion would be to initially learn from projects from Kaggle.com, but that's not going to get you very far putting on your resume like, hey, I did a Kaggle project. What would make you stand out is find this data set, parking tickets or whatever it is, right? Visualize that and write a blog post, share that on LinkedIn. And that's what's going to make you stand out, something that's new, something that's insightful. It doesn't have to be a machine learning model. It can be simple, just visualization of information and getting this new insight from just visualization that nobody else has done before. And that's how you're going to get eyeballed. That's how you're going to get people interested in you and have conversations with you like, hey, how did you do this? This is really interesting. I think I have a business case for this. Would you like to have a chat with me? And that's where things go. Kaggle, honestly, with all sincerity, Kaggle projects will get you only that far, not further.
Got it. Yeah. And then you brought up another point about like Kaggle and utilizing that website for, again, projects. I'm a big fan of Kaggle as well. what's your opinion about these Kaggle competitions? These are actual, data sets provided by companies, so they're considered real data.
Mm-hmm.
What's your thoughts about that?
So participating in a Kaggle competition is different because again, that's new. You're breaking new ground over there, right? You're not copying existing Kaggle solutions that are already there. Kaggle has two kinds of projects, right? One that are always open and have always been open, and you can just go and do projects over there. But if you're participating in a Kaggle competition where you are developing new solutions, that's really great because even if you're in the top 5% or 10%, right, that will make you stand out among other people because you're doing something that hasn't been done before rather than just copy pasting a solution and imitating a solution that already exists on GitHub. And over there, you will be able to genuinely hold a conversation and defend why you took a particular decision on tuning the model, on cleaning the data, how did you fill the null values, and other things which are really, really important to a data science or a machine learning project.
Got it. Kyle, you have anything to say?
Oh no, it's that's awesome. Well, I wanted to actually ask a quick question to go back a little bit in your history. That you said you actually got your first data science opportunity while you were still studying civil engineering. Was there anything particular that you did or like that gave you sort of a breakthrough that allowed you to convince someone that like, hey, I'm studying civil engineering now and I've got a background as a civil engineer, but I might be successful as a data scientist and you should take a shot on me, that someone else can learn from that?
Yes, definitely. So I'm going to shout out over here to Raid Ghani, who's the director of data science for social good at University of Chicago. He definitely took a chance for me and gave me an opportunity to, uh, pursue my passion in data science. And by that time, what I had learned in data science were just these two courses. I had done my machine learning course where we learned about decision trees, we learned about regression, we learned about support vector machines, kernels, and things like that. And it wasn't just applying these machine learning models, it's understanding the mathematics behind these models. It's being able to implement these models from scratch in Python, C++, MATLAB, whatever it is, the language of your choice. It doesn't mean importing a Python package and just applying a machine learning model to a simple problem. It is actually building the machine learning, model, the whole pipeline yourself.
Well,
So
So you'd say then, like, really knowing the nitty gritty details and the fundamentals, the mathematics, computer science, and being able to break that down and implement it yourself is one of the things that you found really helpful to start.
yes, it is really helpful, and it also gives confidence to the person talking to you and interviewing you
Right.
that you are interested in machine learning or you genuinely care about machine learning because you understand these concepts and you're able to talk about them and dissect them and then also optimize these models fundamentally for a use case that might be important to you because sometimes you're doing a linear model and you don't really know about kernels, but once you have the knowledge of these kernel transformations, you really can separate nonlinear data, right, with linear models.
Mhm.
And just showing that understanding, right, that you can visualize nonlinear and linear data, what is it that a nonlinear boundary looks like, and talk about these transformations shows that you have a much higher understanding about machine learning. And honestly, whether you do it in R, Python, Java, SQL, whatever it is, that is trivial. That is the application layer. Once you have a core understanding, everything else is trivial.
Okay, so if someone was just starting out, what are some of those core skills that they'd want to learn? Like calculus, linear algebra, probability, algorithms. Like, what would you say the core starting points are for someone that's just starting out? They're like, okay, I want to learn the details, the nitty gritty. Where do I start? There's so many different things to learn.
So my approach, again, this might not be the right approach for everyone, but this is my approach. The first tab I do at everything is I just brute force it. So I brute force, like take a machine learning course, just go through it. You might suck at it. It's okay. And at that point, when you're going through the machine learning course, you're like, oh, I don't know this. I don't know this. I don't know this. I don't know this. And that's when you make the list of things you don't know because everybody might either know something or not know something else, right? So you need to be able to judge what you know. So just go ahead, take a machine learning course, get into it. It's okay if you fail the machine learning course first time. You will have a list of things that you don't know. learn those things, come back to the machine learning course and see how well you did the second time.
Yeah. So basically like an agile approach, right? Like you're taking action, you're reevaluating, getting feedback, and then taking more action again.
Right? Yes. That's exactly that. That's been my approach for kind of everything I do in life. It's okay if I fail the first time.
Yeah.
Right? It's okay if I fail. As long as I'm improving every time, that's what that counts.
Yeah. Is that like the secret to success? I know it's a question that came in. They're like, hey, what was your secret to being successful? Tell us the secret, Avinash.
The secret to success is brute force. Just
brute
keep trying.
Force.
Brute force. Just keep trying. Don't give up.
And then optimize later.
Yeah.
The only thing that you've got to worry about is that make sure your curve is continuing up just a little bit, like brute force, but slowly improving a little bit each time. Because if you never quit, then the limit is you reach infinity, right? Well, reach infinity, but you
that
keep
actually
improving.
Reminds me of this really common LinkedIn post that I've seen a lot of people share. It's like the compound interest post, where it's like 1.01 to the power 365, right? And it's like if you increase by 1% every day, it's like 37 or 40. And if you are, like 0.99 to the power 365, or like 0.02% or 0.05% of what you are. So it's just, every day 1%. That's more than enough. Don't worry about
every day.
That's it.
Yeah, I mean, if you can improve 1% every day, like you're a beast, man.
Oh,
like
man.
Even just like the tiniest tiny bit, as long as you move in the right direction every day, right? As long as you keep moving in the right direction, you eventually get there, and you don't quit. That's the other thing that you mentioned earlier, is just that persistence.
So I see a question over here from somebody saying that we don't have the finances to constantly repeat the courses, right? And my suggestion over there would be like, you don't always have to take a paid course in the first try. There are a lot of free courses out there. Mm-hmm. Like, go ahead and do them. These are self-paced courses, and these will help you evaluate where you stand at. And that's really good, because even with fitness, right? The first time you go to a gym, you go to a personal trainer, they first evaluate what is it, how much can you lift right now, how much do you weigh, what's your body fat percent. They always take measurements at the start. And that's really helpful to pace yourself and know where it is that you want to grow and what are the things that you want to grow in.
Got it. I have one question that I've seen popped up. So in regards to like what we just talked about like the secret method, brute force, and all the mentality that goes along with it. Besides that, one question that's really relevant is, so back to the subject matter about data science. In this case, R, Python, statistics, linear algebra. Can you give us a little summary about how these topics play some sort of role in data science?
These topics, so these things are data science.
Yeah.
So R and Python would be just, two ways to achieve. R and Python are means to an end. Whether you drive an electric car or a gas car, you're going to get from point A to point B. And that's what is R and Python. R is a little more statistics heavy, and you have a lot more inbuilt functions that statisticians use, and it's really helpful to get some nice summary statistics, to do some nice visualization, quick and dirty. Python requires a lot more boilerplate code for that, to clean your data. R has a lot of inbuilt tools to just clean your data. So R and Python is trivial. It depends what you want to do, where you want to go, where you're coming from. And for most places in the industry, they're agnostic towards R or Python, because if you can pick up R, you can pick up Python. And if you know Python, you can pick up R, and depending on the projects, right? Like my work at LinkedIn, it changes from project to project. Sometimes I use Python, sometimes I use R, sometimes I use Scala. It depends on what the project is. And that doesn't matter much. When it comes to linear, the linear algorithms and statistics, I think statistics is really, really important, because you need to be able to talk data. You need to be able to understand what a confidence interval means. You need to be able to understand what kind of data it is, whether it's sparse, what is the variance, what is the standard deviation, how it is spread, how are you going to compare two forms of data if you're running a test, like if you're running an A/B test. So statistics is the fundamental of data science. And the joke is basically a data scientist is a statistician living in San Francisco. That's all data science is.
Well, maybe at your company.
But so that's my just on it. Like, statistics is very important to data science, but so is machine learning and so is programming. You need to have a programming aptitude. And if you want to get ahead in data science, not only do you need to know this, you also need to know certain programming paradigms. You don't need to be an expert in them, but you need to be able to understand like Git, object-oriented programming, data structures, and certain other CS core concepts like network algorithms. How these play into experiments, how are you going to optimize your data science workflow using these computer science concepts as well.
Well, so let me ask this, because I totally agree with what you just said, that it's not just about programming and syntax, but it's actually understanding the paradigms and how do you apply object-oriented programming or functional programming and different design patterns and stuff. Like, how would you go about learning that if you were just starting? Would you learn the theory of computer science first, or would you just jump in and start coding something and just try to figure it out as you go?
If you want to pick up fundamentals of data science, just get into programming, go to HackerRank, go to LeetCode, look at the interview questions over there. There are a lot of data structures over there like trees, graphs, stacks, and all these other data structures, and just do some tests in the language you're comfortable. If you're comfortable with Python, that's a great platform to learn Python and learn data structures at the same time. So that is a great place to pick up CS skills if you want to learn programming.
Nice. And then, in addition to that, and then just like in addition to the statistics side and building predictive models and stuff, how much of your role as a data scientist has been about, productionalizing your models, taking them, and not only producing an insight that's useful for the customer and the business, but actually getting it out to market so that someone can use it?
So that depends on the size of the company. So if you're working for a small company like a startup that has only 20, 25 people totally, right? You are going to be on point for taking your data science model, the prediction model that you have, talk to the engineers and get it implemented yourself, or, partner up with an engineer and get that implemented. But at a large company like Facebook, Google, Microsoft, LinkedIn, all these teams are siloed. There are people who build these models and, show that, hey, this model is great. But the skill set required to put this model in production for 500 plus million members is a totally different ball game. So we have data engineers for that. We have software engineers for that who we collaborate with, but we don't do that directly. So it just depends on the size of the company. So if you're going to work for a big company, you're going to be in one of many categories of data science,
right?
And most likely they're not going to overlap. But if you're in a smaller company, these roles are going to overlap a lot and maybe, be the same, which is why there is so much confusion over what data science actually is in the first place.
And I think it's team size too, right? Because even at a big company, you could have a very, very lean team with like 1, 2, 3 data scientists that essentially, make you wear all of the hats. How important would you say, if someone's just getting into data science, like, is this a critical skill that they've got to develop, being able to productionalize their models, or should they just focus on the machine learning side? Like, just what's your gut feeling from what you see in the marketplace, like where it's going?
So my gut feeling is focus on just the core skills. Don't worry about productionalization of the models unless that is what you want to do, unless you want to become a data engineer. Like, a data scientist is slightly different. You make the models, you understand the models, you dissect the models, you explain the models. And if you want to do data engineering that is productionalizing the models, a lot of companies now understand the difference between a data engineer and a data scientist, especially the large ones. And it is the data engineers who are putting these models into production. So don't worry about putting things into production unless that's what you want to do.
So I think we saw some interesting questions come through earlier, kind of related to this, but even more future looking. So I wanted to have a conversation with you guys a little bit about that in terms of where do you see the future of data science going as there's more and more tools that allow companies to automate some of this stuff. Is it really a good field to even get into, or is it going to become completely automated and obsolete in 5 years?
So my gut feeling and what I'm seeing in the industry is it's not going to get obsolete anywhere in the next 5 years, because big tech companies have been collecting data for a long time now, and they're just figuring out how to use the data, how to leverage that data for their products. Even now, Google, Facebook are still just collecting a lot of data without actually knowing what it is that they're going to do with it. And in this era where storage is so cheap and abundant, companies are just storing their data and they're going to figure out what to do with it later. And a lot of this data is dirty and not clean because they still haven't figured out what they want to do with it. So data science is not going away anywhere in the near future. And even if things get automated, it still brings more power to the data scientist. You still need somebody to figure out what to do and which computers are not going to be able to do it. Yes, they're going to be able to automate a lot of things. You maybe don't have to clean the job. Maybe, deployment to Tableau or business, the Microsoft Power BI or any other visualization tools becomes much more easier in the future. But what it is that you want to visualize is going to be decided by the data scientist and not by a computer, because they don't understand the problem. They won't be able to empathize with the users, which is what a data scientist has the most power to do.
Right. So it sounds like domain expertise and empathy, understanding the end user, what their goal is so that you can help them be more successful, are two things that a computer can't really automate.
That is definitely true. And a lot of people are asking like, hey, should I be learning Hadoop, Hive, all these things? And my take on that is like, those things are going to be changing, right? Every 3 to 6 years, we go through a whole different, era of tools and technology. Just to give you an example, when I was in the Data Science for Social Good program, we were working with with Spark ML. Spark had machine learning libraries inbuilt, and that has become more and more advanced. And previously, it was in the form of Mahout, which got deprecated and no longer exists. And now everything is in Spark ML lib, and things change really fast when it comes to big data. So don't worry about what it is, which language you're going to use, what it is. As long as you have the fundamentals, the language, you will need to keep learning. You will need to keep picking that up as we move along, because older languages are going to get obsolete. There are going to be new features. There are going to be new languages. Even in Python, there'll be new features for data science, right? Pandas is going to be evolving. Scikit-learn is going to be evolving, and you need to keep up with that. So it's going to be an ongoing journey of learning in data science.
So you mentioned about like keeping up to date with all these tools and technologies. For these students that are new, in this case, they're lost. In your opinion, what are some of your favorite websites or maybe articles or research papers that you find helped you out during your journey, during your path to data science?
So KD Nuggets is KD Nuggets is one of my favorite websites to go on to for anything related to data science and machine learning. Also, keep an eye out for conferences like KDD and NIPS. The papers published over there are really high quality, and in most cases are open to all for download, right? And you don't need to be a part of a university or anything to access those papers. And then this is a little offbeat, but one of my favorite sources for machine learning info is Reddit. Like if you go to the subreddits for machine learning, you go to the subreddits for programming, Python, they are filled with, nuggets, like really interesting papers that you're not going to find anywhere else. So that is my favorite source in that particular order.
Got it.
And if you guys don't use Reddit, you should check it out. It's amazing. No? Kyle disapproves.
It's okay. I mean, there's a lot of different good resources out there, right? There's a lot of
Yeah.
different people in the community that have different preferences and stuff. And I think one thing interesting that you mentioned is going to conferences as well. I know that conferences are interesting because you're actually able to network and connect with people in person, which I think is really valuable, and learn what they're doing at their companies and stuff. So I think that's a really good one. Me personally, I prefer like the in-person connection versus the anonymous Reddit, but there's definitely different good sources of information out there for sure.
Yeah, so back to that, like the pros and cons of conferences, meeting people and looking stuff online. The biggest benefit for any conference or like personal webinars like this is you get the chance to see and communicate with these people. You get to see what's happening real time. So I think that's the biggest value in terms of these conferences. But yeah, that's my say.
Definitely. And also sometimes, so a lot of people don't really need to attend the conferences. My suggestion is to just take a look at the papers that are being published at the conference and the posters that are being published at the conference. Many of these conferences, after the conference, will also, release the video recordings of the keynotes, and you can always take a look at that. And more or less, if you have an email address with .edu, they will let you access it for free. So that is one thing to keep in mind. And you don't have to attend the conferences. Just look at the papers, download them from Google Scholar, and then, put yourself in, put your reading hat on and then read those papers and try to understand what the authors were trying to do in those papers. And it's really insightful.
Yeah, absolutely. I think that's a great tip, because I know that I was looking at the chat here and some people are like, I can't afford conferences. You have to fly there. It's kind of a big hassle, but they post the papers publicly. A lot of times they post the videos afterwards. Just watch them, like get exposed to what's going on. I think that's a huge help.
Yeah. So, and then look back to the good conferences. I've heard good recommendations on PyData.
Oh, yes.
Do you have any recommendations?
Yeah, Kyle and I attended a PyData conference once together, and that was really helpful. And I think the PyData is sponsored by, I forget who, but they make sure that they release all their talks on YouTube because they come from an open source background, and all the GitHub repos related to the talks are also open sourced. So check out PyData. That's an amazing resource too for doing data science with Python.
Got it. Let me write it out in chat.
I'll probably go to the one. I think there's one coming up in Los Angeles next month.
Oh.
I think so. I'll probably be there. In case we got anyone else local here that wants to join. Yeah, it should be fun.
And one more tip would be, like, if you're a student and if you have like a student ID, check out GitHub student developer packs, and a lot of other tools have free packs for students. Like JetBrains has free community edition of their tools, which are really good tools to use. So personally, I use the PyCharm IDE for doing my development in Python. I use Jupyter Notebooks for my developments for scripts. And take a look at these tools. Like IntelliJ has really good tools for free tools for students and free community editions. A lot of the other tools in Python are open source and free to use. So that's a great start.
Yeah. Okay. I totally agree. I mean, that's what I see being the most prevalent in the industry too, is PyCharm being used a lot, and then Jupyter Notebooks being used for like exploration, before things are ready for production and stuff. So guys, like Avinash said, it's free, especially if you have a student email. But there's a free edition even if you don't have a student email. Check out PyCharm. It's definitely a good IDE.
Yeah. And also, the best part about Jupyter Notebooks is GitHub supports Jupyter Notebooks 100%. So it supports the rendering of GitHub Notebooks. So you could share your analysis with comments, what you're planning to do on GitHub, and have your portfolio built using Jupyter Notebooks.
Oh, you mentioned like portfolio. So that brought up the attention of the importance of documentation. So if you're early off in your career and you want to start your project, what's your thoughts about documenting your work, whether that's commenting, whether that's formatting, writing your report, all of that?
So the hardest part is to do it. And my suggestion would be, like, again, just start documenting it. Don't worry about the quality of the documentation in the first pass. Just document, have a complete brain dump of what you're doing. Because sometimes when you come back to the project in 3 to 6 months, you'd be like, wait a second, why did I have this parameter here? Why did I have this parameter there? So think about talking to your future self about this, what you're doing. And it's okay if you over document. There is no issue if you over document. You can always ignore it. But the problem is when you under document and you don't really remember why it is you set the seed to 500 or set a certain value to, something like a random forest cutoff or something, why you did that in the first place. So just document everything. It's okay if you over document. It's okay if the English is bad. It's okay if it's not grammatically correct. Just do it. You can come back in the second pass and update it.
Yeah, and I think that's, Avinash, that's a great point and part of like a broader ideology of like defensive coding, right? You don't necessarily code to be as efficient as possible and to make everything as perfect as possible, you code to make things not screw up. Like you want to prevent something from being a catastrophic failure in the future. You want to make sure that you document that things are like protected, right? As a overall ideology. Do you see that that's a challenge for data scientists sometimes, that they don't document their work or they don't explain a model, and then they come back and look at their code and like, why is this value 0.49? Does that mean something?
Yes, and I'm guilty of doing that myself, not documenting my code many times because you're like, oh, I'm in the zone. Let me just, finish building my model, finish doing this, and then you have your output of results and then you forget about it. You continue on to your next project and you never come back to this, right? And yes, it is very hard, but you should always document your code. And especially in data science where you're discovering new things, right? Let's say you tried a previous model, that didn't work. You try a next one, that didn't work. You're changing the values. So you need to make a document or document what are the past values you used to and why that didn't work, and remind your future self not to reuse these values again and save yourself some precious time in the future. Like, hey, I tried a random forest, that didn't work. I tried XGBoost, that didn't work. Looks like tree-based algorithms don't work on this. So let's, comment that like, don't use tree-based algorithms. They don't work on this data set. Let me try something else. Let me just stick with kernel methods, or let me stick with linear regression. That seems to be working best. I don't know why. I'll get back to it later, but tree-based models don't work for this data set. Comment that, save it in your code.
Nice. Very nice.
Yeah, and then I have another point. So another question is, like, when you're starting, and I know feedback is crucial, meaning if you're new, you have no idea if you're doing it right or if you're doing it wrong. So back to you, when you're starting data science and you're in this field, what's your thoughts about feedback and how did you share your work to improve yourself?
So feedback is really important, and you need to take it from a very non-personal stand. So if somebody says like, hey, there's something wrong with your methodology, so there's something wrong with, your data cleaning method, and you realize that, don't take it personally. It's okay. It happens to everybody. And instead of defending that, step back, take a critical look at your whole process, like try to walk yourself through it, whiteboard it, rubber duck the model, whatever it is. Just talk to somebody about the model and you will realize certain mistakes that you might have made when you're just talking to yourself internally. Try to explain the model to somebody else and you will get feedback from them. And things happen. You always make mistakes. That's okay. That's human. And the thing is, you go back to the mistake and correct it and realize why. If it was a mistake, it was a mistake. If it wasn't a mistake, then you try to explain your approach and be like, you know what, the problem is that the skew in the data is too much and we can't use this model, hence we use this data cleaning method. Because sometimes you try to fill in, like a common problem that I have is like filling null values, right? And you have skewed data and then you're like, oh, let me fill it with a mean value. But that doesn't work. So you just fill it with NAs or zeros, or you just drop the column. And then somebody's like, oh, you didn't use this really important column. And that time you either go back and reevaluate your method of filling in drop values, or you defend your method.
Got it.
Hey, I noticed something you said a couple times that you used for examples, random forest, and you mentioned gradient boosting. Now, I know you know what I'm going to ask. So there's a question that came through. Someone said, like, what's your favorite machine learning model? And more generally, probably, I'd want to ask, what models do you see used most often in industry?
So I'm going to go quote somebody from KDD. Like this was in an actual presentation I saw, and the quote went something like this. It's not verbatim, but why do we need a more advanced model? Everybody uses decision trees anyways, or everybody uses random forest anyways. And it just so happens that any tree-based model, so it might be XGBoost, it might be, random forest or simple decision trees, they're very versatile. They're very versatile. They can adapt to a lot of different kinds of data. And at the same time, they also tell you the feature importance. So they have a good balance between predictability, recall, precision, and at the same time, you understanding what exactly is going on in the model, why it is the model's working the way it is. And it scales well with large amounts of data as well. So that is one of the most common algorithms used, machine learning models used in the industry. But yeah, 90% of the companies, their use case would be satisfied by a linear regression, right? But people don't want to accept that. People want to try neural network on their data set that has only 200 rows. And unfortunately, that is not going to work, and you need to be cognizant of that.
Well, so all right. So to recap, random forest good, decision trees good. Um, but
Trade baseball, good.
but to your point at the end, do you think that there's an issue right now? There's like a disconnect between what companies think that they need in industry versus what they actually need? Because you said 90% of problems could maybe be solved with a linear regression, but companies don't like to accept that. Do you see a big issue that there's this gap that like we need advanced AI, and then a data scientist comes in and like, linear regression will probably work for you?
Yes, and that is true. I've observed it firsthand. Everybody wants to be up to date and wants to use the newest technology, whether it is applicable to them or not. And it's a problem because if they don't use those technologies, they're having difficulty attracting talent as well, right? Because really good talent wants to work with new technologies. They want to work with the cutting edge methods. And if you tell like, hey, I just want somebody to do a linear regression, they're going to find it hard to bring in talent into their company. So that is one thing where they might, say like, oh, we are going to do these cool machine learning things, and 90% of your job you're either doing regressions or data visualization or simple slicing and dicing of data and presenting different cuts of data. You some 50% of the time you don't even get to a machine learning model. A lot of the insights are just generated by slicing and dicing the data, visualizing it and finding the patterns and leveraging those patterns to improve your product or improve business decisions. So you don't even get to the machine learning part for a lot of use cases. And then when you do, a lot of the use cases are solved by simple regression or decision trees or XGBoost. Very, very few cases actually require deep learning.
So then,
So there is a disconnect, yes.
yeah. So I mean, it sounds like back to one of your original points that it's really really critical to have the empathy and domain knowledge to be successful as a data scientist and to understand the business problem and your user and what they need. Awesome.
Yeah. And actually, there's also true. I just saw somebody saying that G is asking for 4 years of experience in TensorFlow, right? And I don't know when this happened, but I've seen people post ads for jobs for technologies like 10-year experience in Spark, whereas Spark has been out only for like 6 years or 7 years. And a lot of companies don't really know what they're doing with data science, but they just want a lot of senior people to work on data science. And hence they have these really ridiculous asks for 5 years experience in something that just came out 2 years ago.
Yeah. Well, to that point, because obviously I've seen the same thing as well, and I've gone into companies where they were very immature in data science, and I had to help bring them along. Like, what percentage of your role as a data scientist do you think is just evangelizing data science? Right? Like, what percentage is just like teaching other people what data science is, explaining it to them, getting the buy-in, helping them understand? Because clearly a lot of companies just don't know. They're asking for things that are impossible and don't make sense. So what percentage of your time do you have to just educate people about it?
So fortunately at LinkedIn, we are a very data-driven company, and actually data science was coined by DJ Patil, who was during the last administration the chief data scientist of the White House. He was at LinkedIn. He pushed data science at LinkedIn and developed the whole idea behind data science. So at LinkedIn, we don't have to push the idea of data science. We already have a huge analytics team. We have a data science team that people come to us for, information, insights, and things to improve the product. So we don't have to sell data science, but you need to evangelize your results. So you need to sell like, hey, this result is really important. We should be taking this seriously. And that is something that comes with any job and is not mentioned or spoken about in school, grad school, whatever, in many of the courses also. And you need to be good at selling your idea. You need to be good at selling your analysis. You need to be good at convincing other people why your analysis is worthwhile. And yes, I'd say around 30 to 40% of a regular data scientist job would involve in them selling their idea. unless of course it's a really small startup where you don't have to convince anybody and you just implement it yourself.
What's one tip you could give that you found useful when you realized like, oh shit, I can't just produce a result and hope someone picks it up and uses it. I actually have to sell this. I have to explain it to someone and show them that it's useful. What's one tip that you learned that helped you be more successful in that regard?
So it takes time, but there are a couple of courses out there on storytelling, and those are really nice. Like you might think it's totally disconnected from data science, but you need to tell a story. The more engaging, you need to have a hook, you need to have a premise, and you need to have all these elements of a story to hook someone in and convince them of your analysis. And so a course in storytelling, I don't remember the course off the top of my head. I can share it later on my LinkedIn profile or via Kyle, but storytelling is something that's really important. So, and or communication skills as well. So it comes back all to that, like pick that skill up. Nobody teaches that in grad school.
Right. So back to the storytelling for you, is there a particular structure that you follow whenever you're doing a report or a presentation?
It depends from project to project. There is no one size fits all. You need to gauge the audience. If you're speaking to a really high level audience like the executives, you don't have a time for all the technical methodology. You need to convince them of how this is good for the members in the business. But if you're presenting to a pool of fellow data scientists, you need to go into the methodology like, hey, this is what I did. This is what we did. Can we review the whole methodology? So it depends on the audience, whether you're selling it to data scientists, mid-level executives, or high-level executives.
So it goes back to the empathy and knowing your audience.
Exactly.
What does your audience need?
True. Awesome. So that's pretty much it. Is there any more questions or?
There was one personal question for you from, let me read the name. It's from Pralika. So it's very personal, saying, thank you so much for this session. I would love to know what a typical workday is like for you at LinkedIn.
So I can talk about a typical work week because days shift a lot. Sometimes, depending on the day, I have a ton of meetings and I'm just talking to people about the work they have done. I'm talking to people about the work I have done. But for any day, my work could either involve sharing my work with other people, grabbing coffee with other people and just learning what they're doing without any agenda, like no agenda, just learn what my coworkers are doing so that I have a holistic idea of what LinkedIn is doing as a company, because it's such a huge company. You need to be proactive in learning what's happening in other parts of the company and whether you can leverage that or if there's any partnership you can form within the company itself, within, two different verticals to leverage each other's work. So talking to people, evangelizing ideas, maybe 50% of my work week goes in just actual coding, where it's might be pulling the data from SQL, from Hadoop, building models, doing code reviews and things like that. And the remaining 50% would be attending meetings, evangelizing ideas, building decks for storytelling, and talking to other people.
Got it.
And hey, what if you expand that even more? Like, tell us. I know that I rushed through intros at the beginning because I was so excited to get talking and to get feedback from you. But can you share for the audience a little bit more about yourself? Like, what are some of the things that you like to do in your free time? Where can people see updates from you in the future?
Yeah, so definitely, this is a good point, actually. I've been meaning to start a blog on data science and my journey, and I will have the link up soon on, hopefully by the end of next week on my LinkedIn profile. So keep an eye out. It's probably going to be just a Medium, blog post and articles on Medium. But in my free time, I do a bunch of random things. Like I like photography. I do a lot of DIY electronics, build stuff from deductibles. I love playing with the Arduino, Raspberry Pi, and all the IoT stuff. I like running, cycling, hiking, all those Californian things. This happened after I joined LinkedIn. It's typical California, yeah. And that's pretty much it. So like on the weekends, I definitely devote some time to my health. So it's either running, going on a long hike, going on a long bicycle ride, taking care of my body, cooking, going to the farmer's market and things like that. always put yourself before work. Like if you are not in a position to do work, it's okay. Take care of yourself, bring back yourself to a position where you're able to focus on the work rather than letting the work get you, because work will come, work will go, it's okay. You just lost some time, but you really need to take care of your health, your mental health, physical health, eat properly, and take care of your body so that you can perform optimally in all other aspects of your life.
True
Yeah,
that.
yeah, absolutely. I mean, you're not going to get anywhere if you're not healthy. You're not going to be a good employee. You're not going to be able to learn and grow and improve, and you're not going to be happy either. So definitely happy to hear that. Randy, I know that I can stick around forever, but it's like 4 a.m. for everyone.
Exactly, yeah. So it's been an hour and 5 minutes already. So we can just wrap this up. And we didn't introduce ourselves yet, Kyle. So if you
No, I just rushed
Everybody
through.
knows
Like,
Kyle. Everybody knows Kyle. Yeah.
Yeah. So quick overview. I'll go ahead and introduce myself at the end. I'm Kyle. I'm the founder of Data Science Dream Job. So it's the #1 job search resource for data scientists. We've got some really cool programs there, and we're also creating some new free resources. And our mission is really to help aspiring data scientists to successfully break into the field, to start their career as data scientists, and if they're already in the field, to take it to the next level. So me personally, my background, I have been a lead data scientist, team lead, or department head for data science at 4 different companies now, 2 of them Fortune 500s. So I've got a lot of experience in data science myself, and I'm currently head of data science for consulting.com. So that's a little bit about me. Randy?
All right, yeah. So I'm a new member of the Data Science Dream Job company. So I'm super happy Kyle got me on board. I love the mission. I love helping out everybody in the data community. So that's everything about it. Other than me, my background is I've been heavy on the e-learning platform. So I've been teaching machine learning and data science courses through 2 different boot camps. So in that regards, I just love helping people in general. I love bringing the community together. And this hope of Data Science Connect, that's what we want to bring through with our ideas, make this happen. And yeah, that's about it for that.
Yeah, and we're really excited to have this opportunity to be able to connect with you guys, to be able to reach out to you, to be able to have these conversations and share it with you and get feedback from the community as well. A lot of the questions that we asked are literally straight off the list of questions that were emailed to us or posted on LinkedIn. So we want to do as much as we can to help you be successful. And again, these are focused on connecting with different people in industry. So if you guys ever have a suggestion of someone that you want to see join us on here, or if you want to vote to bring Avinash back again, because I'm sure we could talk for hours and hours. There's tons of stuff that I know we didn't have a chance to get to yet. But guys, just post on LinkedIn, tag us, let us know. We're here to help you. That's really our mission. So like I said, follow us on LinkedIn. Avinash will have some updates soon. Can't wait to have more of these. Like I get really pumped up for these because I love to have the opportunity to help you guys. So I hope that you enjoyed this. Yes, it is recorded. I've got that question like 1,000 times. It's recorded. I'm going to post it. We're going to post it. We'll share the link with you. Don't worry. If your friends weren't able to attend, you don't have to try to hack together some solution. I'll get the link out to everyone pretty soon here, guys. So don't worry. Randy, go ahead.
Yeah, I got one last thing. So I know this is a big community of LinkedIn, and I can't emphasize enough the power of connection and sharing. So if you're working on a project or if you have any questions about data science or anything, definitely tag me, Avinash, Kyle, about whatever question you have, because we're here to help. That's our main goal. And again, when you're sharing your questions, not only will you get your questions answered, but other people are going to learn along with you. That's the whole point. It's a compound effect.
Yeah, absolutely. And thank you to Randy, to Avinash, to every single one of you. Thank you for joining. I appreciate you being here so much. All of us do. It really means the world to us. Huge congratulations if you're here right now. I know it's not a convenient time for everyone. It just shows your dedication. It's like Avinash said earlier, and Randy said, if you keep improving just a little bit, just a little tiny bit every day, and if you be persistent, eventually you're going to get where you're going. Just don't quit and keep improving. And that's really what it's all about. So really just want to congratulate you for being here, and I'll see you guys in the next one.
Yep.
Perfect. Thank you, Kyle. Thank you, everyone, for being here.
Thank you, everybody.
Yeah.
Thanks so much.
Thank you, Randy.
Awesome.
Bye-bye.
All right. Thanks, guys. We'll see you at the
Take
next
care.
one, and we'll get that link out soon.
All right. Tag us
All right.
anytime.
Bye.
Later.
Awesome.